Okay, so in this question we want the gradient at a particular point again. So we want the gradient at the point 2, 3. So we need to differentiate this. Now when you see this, of course, we've got a product here, okay, of 4x times y. Okay, so if I use the product rule to differentiate 4xy to start with, so my u will be 4x and my v will be y. Okay, so I've got the product of 4x and y, so then my du dx, so u dash will be 4, my dv dx, or v dash, well y becomes 1 when you differentiate it, don't forget then to times by dy dx. So the product rule then, v times du dx, so y times 4, plus then u times dv dx, which is 4x times, that'll just be dy dx. Okay, so if I differentiate now this with what I've got, the equation with respect to x, okay, well, x cubed becomes 3x squared, 4xy becomes this, so I've already differentiated it. Equals to then 15 becomes 0, and y squared becomes 2y, of course, because you bring the 2 down, put the dy dx on the end. Okay, so then you group the dy dx's together. Alright, so we'll get them onto the left hand side maybe. So we have dy dx 4x take away 2y. Okay, so I'm grouping these together, so take that over, so 4x take away 2y, and then we'll take these terms over to the other side, minus 3x squared minus 4y, and then dy dx will equal to, we've got minus here as a common factor, so we take that out, 3x squared plus 4y all over 4x minus 2y. Okay, so then we're asked to find the gradient at the point 2, 3. So in other words, what is dy dx at that point? So we've got 3 times 2 squared plus 4 times 3. And then 4 times 2 minus 2 times 3. Okay, so I haven't got my calculator, so let's just work this out. So what do I get on the top? Well, that's 4, so 3 times 4 is 12. That's also 4 times 3, that's also 12. So you get 24 on top there. On the bottom, you get 8 here. That's 6. So 8 take away 6 is 2. So you've got 24 divided by 2, which of course is 12. And there's a minus there in front, so we get negative 12 as our gradient at the point 2, 3.